Hello, everyone, and good afternoon. Hope you're still having fun. I felt very weird just 2 minutes ago. I was in the restroom, and I thought, oh, I'm feeling like Frank Drabin going to the restroom, and everyone in here in the hall hears how I'm kind of going to the bathroom. Thank God the microphone was off. Anyway, so if you're here for learning how to deal ETL with some commercial products. Sorry, that's in the other conference 3 miles down. So what I'm going to tell you, or what I'm talking about, is how you can use Lucee for large data sets, for large files, and how you deal with it, and what I experienced along the way of the last 3, 4, 5 years. And by the way, this is the tool that I use to make me twice as productive, right? So, the talk is about the performance considerations when handling large files with Lucee and what you can do. And I've learned a list of things along the way. And one of the guys that I have to thank is sitting here in front of me. That's Nir. Thank you very much. Nir is an expert in databases. You know, I thought I was a very good database engineer. I did DBAs on MySQL, on SQL Server, and I thought I was good. And then I met him, and then I knew that I know nothing, and that I have to learn everything again from scratch, more or less. Yes, so who am I? My name is Gert Franz, as you may know. I've been involved since the days of this was still active 20 years ago. I'm a DB system architect and a fellow at DistroKid, and I'm a very big CFML passionate and a performance aficionado. That's how you can describe me. I used to have 4 hearts in my chest. Now I have only 3 because of this. One is, of course, my wife, and I have to say that because it's recorded, so she will kill me otherwise. And I have Lucee and I have DistroKid in the meantime as my 2 hearts beating. And the greatest thing is that I can combine the 2 while working for DistroKid using Lucee. It's a dream job, I can tell you. So, and this is my more or less evolution. I started with assembler, and yes, I did BASIC, all the different flavors of BASIC, VBA BASIC, and regular BASIC, and what have you. And then I went to Clipper. Who knows what Clipper is? Well, at least 3, 4 people. That's great. It's a compiler for DBase. Who knows what DBase is? Oh, there you go. True story. The day before my graduation in high school, the teacher was calling me saying, "Hey, my DBase program is not working. Can you help me print out the marks for everyone?" I said, "Sure, why not?" Felt a little like Ferris Bueller. And I knew all the marks just before the next day. So that was kind of funny. Yes, and now since Delphi, Java, CFML, and Lucee, this is I hope my final job, and we'll see. So what is this all about? It is about ETL. Who knows what ETL is? Anyone? Oh my God, skeptics. Good. I hope to make you proud of what we're doing here. So ETL stands for extract, transform, and load. So what you do, you have source systems, can be files, databases, external resources from the internet, from local, from anywhere. Then you transform them, and then you shove them in your target database. And you use that target database for doing analytics. In our case, and I'm speaking specifically here, at DistroKid. Oh, and by the way, in the meantime, you know almost everything what DistroKid does, so you can build it yourself, right? So we have talked so many things about DistroKid lately. So we are using it for distributing the royalties. Royalties is what a musician gets when one DSP, that's what we call digital store provider, like Spotify, Apple, and YouTube, and others, what they pay to the artist, and that comes to DistroKid, and we pass it on to the artist. And you can imagine that those are immense amount of data, huge files, up to 60 gigs each month, and they are increasing and increasing. So I think in total, every month we deal with about 1/4 terabyte of data, right? And that has to be handled through Lucee currently, and I'll tell you why. So what we do is, with this ETL process, so we take our different systems, and these different systems are all in different formats. So you can imagine that it's not that Apple and YouTube and all of them sat together and said, hey, what file format are we going to serve to DistroKid? Oh, what would suit them best? One is even using Excel, right? So just imagine Excel. So they're not very confident because Excel has 1 million rows, that's it. So that means they're not very confident that their artists will really be very successful. Because after 1 million rows, what do you have to do? You have to take maybe a second data sheet in the Excel file, and that won't work. So usually, we're lucky, and it's a CSV file or a TSV, and then you have, for example, files that are comma separated, but in the values, there are commas as well, right? So you have to deal with that. And they're not quoted. So sometimes we had some DSPs sending us a file, and that file was comma separated, and it was not quoted. So we had really wrong values in the columns, and that means everything got mixed up. And we said, hey, sorry, but your file is corrupt. They said, no, not impossible. I said, okay, please give me this file and tell me what the sum of all the royalties is. Okay, it is corrupt, right? So anyway, so let's just redefine. Extract, E stands for extract in ETL, extraction of data. Then we have transform. We transform the data into a normalized version. I call it normalized. It's a term, maybe that's not 100% correct, but they all have the same format. And then we shove them in the data. So it may not be, it might be missing some additional things that you require in your target system. This is what you do in the transformation. Like, for example, apply some business logic. Right? Let's assume I'm sending some songs that have been uploaded to DistroKid to one digital store provider, one DSP, and another one. Now we send them a so-called ISRC, that is the International Song Recording Code, right? That's what it's called. And that's the only thing that they identify it by. They don't know about our internal song IDs and album IDs and what have you, and they don't want to know. Right? And we can't just send them a cargo, which they should always send us back. This is the reference. So the ISRC is the identificator that we are the identifier that we are sending with it. But sometimes they send the title and the artist, others don't. So we have to really massage the data, and we do that in the transformation of the data. And then the last thing, the L, stands for loading, and that is usually that we pack all this data, which is now normalized with all the additional information that we added to it, and shove it into the database. So you can imagine I had a lot to do with this young man over here, our database administrator, because obviously, oh no, this ingestion, we call it ingestion because we're ingesting these reports and put them in the database, and then it's always, this ingestion is taking so much CPU in our database, we need to work on it. And so we sat there and did things. So what are the challenges? So usually it's data quality issues, as I told you before, commas in records which you can't identify. You have complex transformations that you have to do. Maybe you have to look up in some target database, and that's taking a long time. And it is really, sometimes really very complex. Then obviously the performance, and this is mainly what I'm talking about, how you work and tweak the performance when you're dealing with something like this. And of course, how can I scale this? You know, if you have such big data, how can you, for example, add many people or many CPUs or many computers to pluck that apart and then do, I don't know, 10 parallel or something like that? So that is really problematic. We have solved mostly everything in the meantime, but this was from about 5 years ago when I started this. So what do we want to solve? DistroKid imports loads of royalties. They come from very many DSPs, as I said before, in different formats and types, and yes, every month. So that means every time these reports come in, the users expect money. So you know that it's very important. It's your paycheck as a musician. So you're waiting for this every single month, and it needs to be there in time. So it cannot take forever. If it takes forever, you know, we had some users breathing down our neck or some DSPs breathing down our neck, and then whoever's in charge breathes down my neck, because I have to make it fast. So this is more or less how it works. We have all the different musicians making music over Spotify, and then that results in a so-called video claim report. That is one from YouTube, which has loads and loads of data, which is formatted like this. Good. Just a couple of numbers. This is the number of ingestions that we have had since the last, April 2013. That's when we started. So you can see it's a very constant increase of ingestions. The reason why it's like that is because the month is not over, so these are really actual numbers. And this is the amount of royalties, and this is no lie. This is the amount of royalties that we have paid out to DistroKid artists, over $1.3 billion, right, in the last 10 years. And here we have the number of records. You can see that the number of records was there. This was 2020 when I had that chart taken, 3 billion. In the meantime, we're at 8 billion. Right? So it has grown exponentially. And here is the records per ingestion. Since users are staying with us for a longer time, obviously their songs are going to be played more and more. So each file gets bigger and bigger and bigger. When I took over the ingestion part, the Spotify ingestion was 2 gigs. Now it's 26 gigs, right? And that's in a span of 4 years. So you can expect that in a span of another 4 years, it might be 200 gigs. Right? So we have to deal with that every month. And the users are sitting there on the bank page, reload, reload, reload. When is my money coming? So it needs to happen fast. Again, how does it come inside? So we have the reports. We have them all in different kind of formats. They used to go to our FTP server until we found that as a performance bottleneck as well. So now they go to S3. So we have an S3 bucket where we load all of our reports, and from there we are starting our ingestion report. And usually how it just does, we have this ETL process just played out again. So here we have the extraction, and then we have the transformation, and then we load it to the database. Okay, so what do we have to do there currently? Yeah, so we have to download the file from S3. Then it might be a gzip file, might be a zip file. So we have to configure all of that and make sure that we're doing the right things. And it might be, we need to take that input, make sure that everything is in place, normalize it, and see whether everything is formatted correctly. Then we need to assign all the different keys that we need for identifying who that record belongs to some conversions, because sometimes we get the money in a specific currency, and then we have another file which says, oh, here are the exchange rates, so go ahead and apply those exchange rates, so a lot of calculations there. Then this is very complex because we have a song database which has 50 million songs in it, and we have this 60 gigs file that we're trying to ingest. And whenever you do that and you try to figure out, okay, this ISRC, that's this identifier, in our 50 million song table, that's this column. So let's do a join of 150 million records times 50 million records. Well, good luck with that. There are solutions for that, but I'll show you. Good. Then store data in some temporary tables and some summary files, but I'll get into details later. So what you see here is, for example, a part of a configuration file. What I did is I created a common component which deals with it, and then very specific ones for each DSP, because one was red, the other one was green, and they have this kind of format of the fields. The country is in position 1, the product is there, whatever. It's not a real live example. This is just an example, right? And then we have columns which we need on our end, and what their name is in the real file. So this is a configuration that I use, right? It's in JSON. So let's dive in. This is the existing solution that we had it before this. We had a 2 billion record table in our MySQL database. It had 19 indexes. I guess you don't even remember, do you? 19 indexes, and one was a huge covering index for sake of performance, and it was really very slow to add records to it. So several big indexes and not partitioned. I'll tell more about partitions in a second, right? And it took really a very long time to ingest, over 10 days. Now just imagine if you have one big one that takes 10 days, and you have another 49 to go, which might also take a day or two. Just imagine where you end up going when you have to release all of a sudden 50 different royalty reports. And that obviously caused a big bottleneck, so we had to solve that. Good. So I thought I'll think a little bit about the whole thing. So what do I need to do? I need to handle different file types, apply some business logic, and add it to the database, and that as fast as possible, right? So the file containing loads of IDs, yes, those IDs need to be identified with the database, and we need to do that so that we know who gets the money. That is very important. You know, you don't want some IDs to be identified from some other song and whatever, so you need to make sure this identification is really spot on. And again, as fast as possible. So, the reason that, or the things that I was looking at before, at the beginning, should I use an existing ETL solution? There are ETL solutions out there. There's Apache Airflow, Oracle Data Integrator, even SQL Server has its integration services. Then you have Pentaho and Hadoop and hundreds out there. So the question was, should I use those? But as I told you before, our ingestions were already overdue by a couple of weeks. And so the question was also, what should I do now? Should I really go and invest in one of these products, do an evaluation, look at each of those products and just, I don't know, maybe find one, then do the implementation and do 50 configurations for all different ones? So I decided, no, I'm going to do it with Lucee. Now, why am I doing it with Lucee? So, most important is time. It's just simply time. I don't have time to do an investigation of all the ETL products. Then I have dependencies on external resources, like an expert that tells me how to set it up, an expert that I need to pay, and when something's not working, I need to call him up, and that was not something that I wanted to do. And of course, very important, I know Lucee very well, so I thought, okay, let's give it a try. And it took me about 2 months, so you can imagine during those 2 months, that was heavy. That was a hard time because, you know, we were still releasing very slow and everyone's saying, hey, when is this ready? When is this ready? When do we do it? So, okay, I'll tell you the journey about this. So my first idea was use temporary files. Because, you know, when you have a big, very big table with 2 billion records, and you add to that table, it's not only that you are adding records to it, that's easy, but you have to update the indexes. And you have 19 indexes, and one of them a covering index. Well, that takes a lot of time. So that's why we had 10 plus days until a big release went out. So we joined these temp tables with the lookup ones, transform the data in the temp tables, the small ones, and once we have done everything, because you need to imagine, before we were inserting the records and then we did everything with this big table, like the joined 2 billion records with 50 million songs. You can imagine that takes forever. So we transformed the data in these temp tables, and once you have identified everything, we move the records to the huge table. Good. So now here comes the Lucee part. I was thinking about certain things. What is the fastest way to loop through a file? You know, I love doing those things. I love diving into performance. It's like, for example, you tell me I want to go from Munich to Vienna. The map says I'm going to take 5 hours, but it always takes 24 hours. What am I doing wrong? So then I go and analyze your path, and I see, oh, you're going to Salisbury and you watch a movie. Well, There's one. Oh, and then you have a sleepover in that hotel. There's another 5 hours. And that's what I do. So what I usually do is then I'm looking at the individual things that are making up my journey and see how long they take and how I can improve them. So one of them was, loop file. What is the fastest way to loop through a file? In the end, it turned out that loop file is absolutely fine for the moment, because it only took about, 3 minutes to go through the whole file, right, just with the loop file. So it was neglectable. So reading the columns, what do? You have list to array. And I sometimes forgot to add this third attribute. Anyone knows what that does? Mark, you know that from heart. Yeah. Sorry? Yes, exactly. If that one is by default false, then 2 commas, one after the other, just ignores it, right? So, which you can argue whether that's a good thing or a bad thing. So sometimes I forgot that, and then all of a sudden data looked like it was corrupted. Then I wrote my own list to array qualified, which separates comma-separated list, quoted comma-separated lists and everything. And then Misha wrote me a function for this in Java, which I then started using, which is really very fast, and I love it. So the basic code that we were having, this is really a very basic code. We're looping through a big file, so that file has 160 million records or something, and we're then taking the values, list to array, and then we go and identify these values, and put them in a struct, put them in a database, and do the next things. Then we'd validate the input, whether it makes sense, whether we find everything, and then we are supposed to shove the data into a temporary table. Good. Now, this is the last step, insert. And what the first, I just wanted to write this down again so that you know what are the steps that we're looking at here. Good, so we start the loop, read a line, validate, prepare, create a table with indexes for the lookups, insert the record, identify all IDs, inform, get some money, and move the records in the huge table. So this is the job to be done. First results after I did the implementation that I wanted. From larger than 10 days, 24 hours, and 14 minutes. Whew, that was pretty good. I was already very happy, but I thought, okay, but it's still a little disappointing, If looping through a file takes 3 minutes, how come that I'm taking 24 hours to get everything to where I was supposed to be? So here is the details of what we did. Looping through the file, okay, I actually was exaggerating. It's 3 minutes and 20 seconds that it took to loop through the file. Then reading the line and splitting it up, 1,400 seconds. Then we have to validate the input, prepare the insert, and here, look at this. 52,000 seconds to just insert the records into the temporary table, right? Yes, so we have 2 big outliers, which is great. Usually, when you have a chart like this, the usual thing that you would expect to see is that all of these bars are more or less the same height, right? That's where we want to be. That is the optimum performance, right? So for example, if you're having a huge bill from Amazon and you look at all the individual services and you see that those services are all equally expensive, then almost nothing I can do. But if you have one big outlier, you maybe have a solution where that's where I can save a lot of money. And here, that's where I can save a lot of time. So to me, it was clear these 2 things are the things that I need to performance tune. Anyone have any idea what I could do here? Okay, first idea. Oh yeah, bulk index would have been nice, but we have the wrong space. Bulk insert is definitely a very good idea. Bulk insert, just for the ones that don't know, Bulk inserts don't write the log, right? The log is usually used in a database to be able to go back minutes in time to recreate a state that you had before. And if you do a bulk insert, you're just inserting all the records, but that means for this time you don't have a log that's written to your database log. And depending on which table you're using, which table space, ESAM or whatever it was, we were unfortunately in the wrong one. We couldn't use bulk insert, right? So bulk insert, but it's a good direction, because the direction that I went then was this one. I don't insert one record, right? Which makes sense. I mean, come on. That was the first iteration that I did. I insert in records in batches of 200, or in batches. Okay. Bye. Fahr gut. He's leaving. Yes, so I'm inserting in batches of 200 or in batches of 500. And the rest I just left the same. And when you do performance tuning, usually you should only change one thing and then test again and then change the next thing, because otherwise if you change 5 things, you have no idea which one actually was the thing that brought the most success. So we're going from this to something like this. Okay, very simple. Look at that result. We just shove off 13 hours of the whole thing, right? Which is absolutely great. So you remember the bar was, where is it? Here. And now it's, sorry about that, here. So it went from here to there, which is absolutely amazing. Love that, right? So that was the first success that I had. But if you know me, you know exactly that I'm not happy if it's just, I don't know, 11 hours. Come on, I can't get a date with 11 hours. No, that's not possible. So, next thing, what can I do? Oh, question for all of you. Hang on, questions for all of you. Why not use query param instead of what I used here? So here I'm using actual values. So I'm writing the values in there and not with query param. Any idea why? I have a specific reason why. I didn't even try it without query param, with query param. Yes? Yes. Exactly. So this is actually quite slow in comparison to actual values. So if you do query param, not only Lucee has to do more work, also the database has to do more work, right? I didn't test it out because I knew immediately that that is not worth it, but I tried it again. So, hang on. Any ideas what we can do next? We were here. So, there you go. That's exactly my next step. Right, so what I'm doing is I'm creating the table without the index, right? So, come on, oh, where is it? Is it here? Yes. So, I'm not creating any indexes for the exact same reason that I told you before. If you have an index and you insert a record, what the database has to do, it has to create the index. So for me, it was relatively easy. The create statement was without the index, and after I inserted all the records, then I created the index. Okay, we were at 11 hours and something. Let's see, 9 hours 55. Yes, we cracked the 10-hour mark, which is really good. That was already very cool. So if I do this a couple of more times, I even get time back. It will be finished before I press the button. Well, that's the hope, isn't it? So now it looked like this. So index the table was there, which is very small in comparison. So if you have to do the index at the end when all the data is there, it's relatively easy, right? So we are at about 5,000, which is 1 hour and 40 minutes for the inserts. And this was back then around, I would say, 12 million rows, or a little more. And what we now see, we have another outlier, right? So what do? We actually shove all the data in the tables, then we do the identification, and then we inform about the finished task. Now, here I can't ask, what would you do? I could ask, okay, so we're talking about this thing. How could I do that faster? If you want to do something like this, where you are trying to make the identification of a record faster, there are many ways how you can do it, but you need to know what your data is looking like, so that you have some intelligence about it, that you know, okay, what can I do in order to be prepared already when I have to identify a record? So what I did is I actually, so what we do is we can store it in a local cache, right? So whatever I found, I store it in a local cache, like a Lucee struct or something. If I can immediately assign a record, I put it into the assigned table, and if I can't find it, I put it into lookup table, right? In the table which I need to still look up. So hang on, so I have another temp table, right? So now I have two temp tables, one which is the final table where the record will be identified and completely done, and one table which I have to index, which I have to identify, to join, et cetera, and then once those records are identified with the joins, then I move them to the final table, right? Good. Results. Oh, look at that. From 9 hours 55, we got down to 4 hours. And remember one thing, I already published this when it was at 9 hours, and then I said, okay, I'm going to work on it a little more, but we had to get those ingestion out the door. So while this was already working in production, I had a little fun and said, okay, let's get this a little faster. And to be honest, and I hope that I'm allowed to say that we were, for a little time, we were the slowest paying provider, distributor, and for the last 4.5 years, we're the fastest paying distributor. So we went from being late always with the payments, and we even got tweets, oh, they're paying so late. And then all of a sudden, oh, it's so fast, you know, just money hit the bank immediately after the report was out, which was awesome. So it was really, I get goosebumps now when I talk about this. Yes, it just reminds me of the feeling that I got when I saw a tweet, oh, DistroKid is so fast and is paying its royalties. And then I go, oh my God, this is such a great feeling that I had. So this is more like it. But of course, I had a couple of ideas. What can I still do to get these things out the door? So we're now here. You see, and this is a very interesting thing that you should see everywhere. You see these bars, they haven't changed their values, but they get bigger, right? So you notice it's just like in everyday life. If you solve the biggest problems, other problems arise, right? Because you don't have to fear about, war anymore, or about your life or whatever, but now you care about the environment, you care about unemployment. This is more or less the same. If you solve the big chunks, then all of a sudden other issues appear, and now you can deal with them. So you should never work on this one. How can we get this faster? That's not your problem. This is your problem, and maybe that one, right? Okay, and what you can see, you remember before, the sum was here 5,000 for the insert. The insert has been split in two, but the sum is not totally 5,000, it's 4,000. This is because the sizes of the tables is a little different. This unidentified table, this one here, has fewer columns, right? So the insert statements took less. So that was another win. Okay, thought a little more about the record identification. So what I did, in order to shave off a little more time of that, I didn't want to join this 50 million table, our songs table or our albums table, with those small tables. So what I did is I actually prepared a table once a week, which has only what I needed, 5 columns with the identifiers that I was looking up, and then I could easily look up with this one table, which has about, 12 million records, because they had several versions of songs, etc., and I only took the latest ones. And so we save the song and album ID and team ID, who is the one that gets actually the money, and we have that in a specific table. And if possible, if I can load that in the memory, then I can identify the record immediately. I don't have to do an update at all, right? And it is a struct in Lucee that I'm then using to look up. There you go, 2 hours 52. Remember, we were at 24 hours at the beginning. Now we're at a little under 3 hours. Yeah? And then I got kind of, I got kind of greedy and said, okay, I want to crack the 2-hour mark. So this is the results. You see, again, these other ones get bigger and bigger, and this one gets smaller. As this one gets smaller, we're getting the other ones bigger. Okay, what else can I do? And this was where I got a little creative. And actually, it helped a lot. He didn't like it, but it helped a lot. So what I'm doing first, I'm inserting 50,000 records into batches of 500 in either the identified or the non-identified table. Then I go and I identify all the records from the unidentified table and I identify them, and then I shove them into the other table, right? So what I explained before. So I start over. Now, here's the trick. Or anyway, any idea what I could have done to shave off some time? And we have done really almost everything possible. I looked at this from a Lucee database perspective. So here, the preparation is more or less a Lucee database thing. And then the identification is all database. So while Lucee is very busy, while this happens, it does more or less nothing. So I thought, okay, let's thread this. So I was threading it. So now what I have one thread which does that, and the other thread which does that. And at the end, I'm joining them. So I'm doing this one. Once that's done, I'm kicking off this one and do this one again. So, and then I wait until both threads are done so that I can continue again. So that was it. While the DB is working on identifying the records, we read and insert the next records, and we wait until both of them are done. Final results, yes. 1 hour and 50 minutes. That was the final result. And so I got something which was actually taking 13 days and something down to 2 hours, doing the exact same thing. And it is important to know that you need to know your data when you are working on performance tuning something. Good, so the release, now we have every data prepared, and we have all the identification, we know who gets the money, we know what it is, etc. Now we get it in different currencies and everything. So what we do is we just put in the amount that we're paying out, and then the data is shoved to this big table. That was missing in the whole equation before. So everything that we did before was preparing everything to be released. And that took 4 hours in addition. And that 4 hours in addition was just something that we wanted to improve. And we haven't done it in the end. We have done it in a different way. But what is the possibility of what you can do when you have huge tables where you want to have a very good performance? And that's something that I learned from Nir, is to partition the table. Does anyone know what a partitioning table is? You know it, 2, 3, yes? So what you do is you actually take a definition. The definition of partitioning looks like potentially like this, can be anything. You can just say, okay, I have my table partitioned into several subtables, more or less, right? So you can say, for example, I do them by month. So every month I start a new partition, right? And you define that in the create statement. And the cool thing about this is they are handled like individual new tables. So if you do an insert on one of the new partitions, when you do an insert on the new partitions, then obviously that will just be treated as an empty table. So the indexes are small there, and you can just insert into that table, right? That's pretty cool. I didn't know about this before because a SQL Server, supported it, but we didn't use it back then. Yes. We can insert the records to this table, and it is as if it is an empty new table. Yeah, but what you can also do is you can create a separate, completely empty table, fill that table with all the data, and then you just apply this thing here, exchange partition, which is a thing that takes a millisecond or something. So you go from 4 hours to next to nothing. And you just do alter table, whatever, exchange partition with this new one. And it's just there, right? So instead of 4 hours, nothing. That's cool. I really like that. Just along the way, what I noticed, that method calls, if you have components in Lucee, methods calls are quite expensive, right? So what I'm doing is I'm actually inspecting the component that I'm using. I'm inspecting it. I do get metadata on it and see what methods it has. Because the master class that I'm using, the super class, implements the lower one, and I might have some methods in here which I'm overwriting because I need to handle something specifically. So what I do is I do a metadata, get metadata of this component, and if a specific method does not exist, I don't even call it, because calling it takes a long time. I mean, a long time. If you have 190 million records that you have to loop through, and you have to call that X amount of times, then that can take up to 5 to 10 minutes. And with 1 hour and 50 that we had in the end, well, 10 minutes, well, we wouldn't have cracked the 2-hour marks without that, right? Okay, then throwing errors is very expensive. So if you're handling data, don't throw errors and rely on them and do something like, okay, I threw an error, okay, I know that there is an error, and you're even expecting an error. That is very expensive because Lucee has to build up the stack trace and everything, and that takes some time. What I usually do, and we do that now with the new way how we're approaching it, I'm generating code. Because when you have everything in a configuration file, you build up a configuration struct, and that configuration struct has, okay, this thing is at that position, this thing at that position, this is the comma separator, and whatever. And if you use this dynamically everywhere, that is really slow, because Lucee has to go, okay, this is that struct, inside is that struct, inside is that value. So what I do is I take that configuration and generate CFML code out of it, which I then use, right? Where it says, take position 5, then position 6, then position 7. The code has really the actual values in there, right? So I'm generating code there. So this is the result of that generation. So instead of value of config fields ISRC, is just values of 7. Right? That's a lot faster. And then you can just generate that by analyzing the configuration, write a snippets file, use that snippets file, and delete it next time. Right? And exiting early, that is something that we do. So for example, YouTube sends us a huge report, 60 gigs, 30% is only values, 70% is empty. So what I do, for example, go to the right, see if the last one is a comma 0. If it's comma 0, then just skip. Go to the next row. Been got it. Good. Oh, this bit me, really. File info versus get file info. I remember starting the ingester, and then all of a sudden I was just sitting there waiting for 5 minutes. Nothing happened. I thought, well, I'm not doing anything. So I used something like the thread analyzer that we had, and then it stood in this line, file info. What's so weird about file info? Well, file info gets a checksum of the file that you're looking at. And if you're having a 60 gig file, well, there goes your performance. And get file info does not, right? So when I changed that, boom, it just started. But I never could explain that in the past. Deep structures that I told you. You have struct, instruct, instruct, instruct. Assign that to a temporary variable and just use that temporary variable. A lot faster. String concatenation, big thing. Don't use string, ampersand, string, ampersand, string. Just write everything into an array, and in the end, just do array to list. Right? That is way faster than string concatenation. Just as an example, if you're having a huge string and you want to append something, what Java does in the background, it creates a new string, copies everything over, and just adds the rest. If you do that all over again, it grows exponentially. So just be careful with that. Yeah, query streaming is not important right now. I got help from the Misha, from the core team, who gave me this method. I'm sorry, I shouldn't have used that effect there. This is just a way how I can stream through a file and it gives me results. So that is Also very good if you have one of the core developers of Lucee on your team. You can just say, hey, Adobe ColdFusion does that a lot faster. Oh, hang on a minute. And then 10 minutes later, I get a function. Here you go. Good. This all happened 2 years ago. And files are really partly 10 times bigger. And in the meantime, we don't do it like this anymore. What we do, we take all the reports, write identical structured files to the local system, upload them to S3, and use Redshift to ingest those in parallel. And it's just, it's a blast, right? Okay. So this is what we do now. We are moving from the old ingester to the new one. And Redshift is absolutely awesome. And the ingestion process is very simple because they're dealing all with the same tab-separated files. No empty records in there anymore, so it's super fast. Okay. Good, and it's really scalable. Thank you very much. Questions? So, any questions?
How long did it take to work through that process?
So, the first initial process that I built took about 2 months, right? Maybe 6 weeks. After 6 weeks, I had, I guess, the 24-hour solution, because, you need to do a lot of configuration work. You need to understand. The most complicated thing was to understand how the data of the DSPs looks like. Because, if the wind is coming from the south in South Africa, then the report of Amazon looks a little different. So I had very many configuration files that I had to build, and that was the most time-consuming. Building the ingestion process itself was fun and was fast, but dealing with all the different types and everything in Excel and what have you was a little problematic. Yes? Okay, so thank you very much, and have a great rest of your